Hey AAF students, this is super exciting. In this lesson, we are going to be doing multiplication of matrices. So at this point, you have done some work of the basic operations, and if you recall, hopefully because we were just doing it, they were addition. Basic was adding, subtracting, and what we referred to as what it is called is scalar multiplication. Right? And in order to do addition and subtraction, your matrices had to be the same size, right? They had to be the same order, is what it's referred to as. Right? So you had to have like a 2 by 3 plus a 2 by 3, or a 2 by 2 plus a 2 by 2. For scalar multiplication, you were just multiplying by a coefficient, right? We also did some solving equations where like maybe you had a matrix plus some other matrix that you're missing equals some other matrix, right? Where you're just applying these basic operations of addition and subtraction and scalar multiplication, but everything, if you're adding and subtracting, had to be the same size. They had to be the same order. It's a little different when we're dealing with multiplying matrices, and I really want to emphasize that like you need paper and you need space when you're working, and you have to work neatly and carefully. And you do want to show what I'm going to refer to as a work matrix. Ooh, that's not spelled right. So that that is really showing us your thoughts and your process, and then it makes it a great way to be able to go back and check your work and identify where any errors happened. Without this work matrix, if something is wrong, it's just wrong. Like there's no way to identify where the error is or where the issue is. So like if your matrix is wrong, it's just wrong. So we're going to apply the matrix multiplication algorithm to successfully determine the order and multiply the matrices, right? So the order is the size of it, the rows by the columns. So a scalar multiplication, each element is in a matrix is multiplied by a constant, right? So when we did something like this, you're just distributing that -2. Something like this, you're distributing that 4. Something like this, you're distributing that -5, right? And it goes to every element of a matrix. When you're dealing with matrix multiplication, I'm multiplying two matrices together. I'm going to be multiplying the rows times the columns. You can only multiply if the number of columns, take a moment to process this if you need to, the number of columns in the first matrix equals to the number of rows in the second matrix. Okay, so it has to match up. So what I mean by that is if I'm multiplying these two matrices, if I stuck an addition or a subtraction sign, you would be like, hold on there, you can't do that, right? And you would say undefined. It's not possible. In something like this, it is when we're multiplying. So the dimensions are, this is 2 by 3, this is 3 by 2. So the number of columns in the first matrix is equal to the number of rows in the second matrix. They match. Therefore, the order of my answer matrix, of my product, is going to be 2 by 2. Okay, I'm going to be multiplying the rows of the first one by the columns of the second one. What this means is the order means, it's too messy. The order we multiply matters. It matters a lot, right? I can't take this matrix. Let's say this one was A and this one is B. If I switched them, I would have a 3 by 2 times a 2 by 3. I would end up with a 3 by 3 matrix, right? Whereas here I'm ending up with a 2 by 2 matrix. I can't multiply in either order. A times B is not the same as B times A. They are not equivalent to each other. So the order you're doing it in matters. So let's do an example. Let's do this first one. So I'm going to take the rows of the first one and multiply by the columns over here. This is what I'm going to refer to as my work matrix. you should have one too. Okay. So I've got 2 times 3, negative 1 times 5, and I'm adding them. Then, so this is row 1, column 1. That's why this is 1, 1. That's the element, right? Row 1, column 2. That's going to go right here. Row 1, column 2. Okay, keep that in mind. So I'm going to have 2 times negative 9 plus negative 1 times 7. And then this is row 1, column 3. Think logically. 2 times 2 plus negative 1 times negative 6. I'm writing this out, and you should be too. I'm doing this, I think it's fun, but you should for other reasons as well. It's a work matrix, 3 times. So now this is my second row, my first column. Second row, first column. Right? That's why it's 2, 1. Second row, first column of my answer. 3 times 3, 4 times 5. Second row, second column. 2 times, this is second column, this is third column. 3 times negative 9, 4 times 7. My second row, third column, 3 times 2, 4 times negative 6, and we're adding them. Right? And then we can simplify. This stuff we're not doing anything in a calculator right now. Right? So this is mental math here, and that's why this work matrix is so helpful to us, right? So I end up with the product is this, right? So I've got 6 minus 5, negative 18 minus 7, 4 plus 6, 9 plus 20, negative 27 plus 28, 6 minus 24, right? So there's my final product. So a little different, right? So this is why this isn't referred to as a basic operation. Let's do another one. So maybe you want to pause the video and try it. Dimensions are 2 by 3 and 2 by 2. So, oh crap, they don't match. So we can't multiply them. Right? I can't find the product of these. This is undefined. Let's do another one. Ooh, let's see what happens here. So I have, well, this is like an equation, right? This is my first row, my second row, my third row, and my first column. So that's why when I multiply them together, so I've got 3 by 3 times 3 by 1. So I end up, these match, check. So I end up with a 3 by 1, which look, I do. So I'm going to be setting up some equations here, right? So first row times first column. Check this out. Bam! 1 times x, 2 times y, negative 1 times z is going to equal to negative 1. 1 times x, 3 times y, 2 times z, when I sum them up, it's going to equal to 7. My third row, first column, 2 times x, 6 times y, 1 times z equals negative 8. Whoa, how neat is this? It's a system of equations, right? Where we could then solve using what we know about systems, right? Like I could take we could tie this all back in, right? And I could add down, and I'm going to get 3x plus 8y. They cancel, equals 9. Right? I'm not going to do the whole thing, right? But I could solve using system of equations. This really ties in. We did 3 by 3 systems. Pretty neat. This is going to come back. What about this one? You guys try this one. Right? So we had a 2 by 2 times a 2 by 2. They match. Therefore, my product would be 2 by 2. My answer should be 2 by 2. And multiply the row by the column. Got a nice work matrix. 0 times 4, negative 1 times negative 2. First row, second column. 0 times negative 3, negative 1 times 5. Second row, first column. 1 times 4, 0 times negative 2. And then my second row, second column, 1 times -3, 0 times 5. So you've got 2, when I simplify that, right? So again, we are not leaving this out. You should be doing a work matrix. Always, that is the expectation. Okay. So this was just an introduction. We're going to be doing this together in class. And then you will have another like summary video on multiplying matrices. There's tons and tons of practice. You guys have a Delta Math assignment that is, or activity that is due not this week, it's actually due next week. But we ask that you get started on it so that you can come together and we can take a look at what you've done. And what kind of help you need with the algorithm. So there's some that's guided and there's some that's practice. It's a total of 15 questions that you should be getting correct by the end of all of this. So please make sure that after you've watched this, you go ahead and do that. There's also a variety of other practice resources like worksheets with answer keys. There's a worksheet that has a ton of problems on it that use and practice these, like really practice writing it out, because the more you practice, the more you'll really get the understanding and know like what errors do you commonly make, right? And make sure your work is organized. So hopefully this was a nice introduction to multiplying matrices and you know what questions you might have, and go do some practice. And we will see you guys next time.